Hello there, and welcome to another AVS deep dive topic. My name is Matthew Webb, and we are going to go a little deeper on something that is near and dear to my heart: vSAN storage monitoring and performance. Storage performance can be a hotly debated topic and very confusing. My goal is not to explain the wide ranging variety of performance topics, but understand how vSAN works and how you can use the integrated tools to monitor and address issues should they arise. This video will be shorter and similar to a webinar that was also posted on this channel. So if you find this topic interesting and want to learn more, please check that out as well. To get started on this topic, we have to start with the architecture of vSAN. As of recording this video, Azure VMware Solution is currently on the original storage architecture, or OSA. There is a new architecture in vSphere 8 and later that customers can adopt in customized vSphere environments called Express Storage Architecture, which AVS does not currently use. So this overview will be specifically on OSA. So let's start off by discussing how vSAN is an object-based storage system, not a block-based or file-based storage subsystems that are of storage arrays of the past. The object-based orientation allows for performance and scale by cutting up objects like virtual disks into small pieces and spreading them throughout disk groups in a vSAN cluster. This unique design allows vSAN to not be limited to what an individual node's storage provides, and allows all resources to be used in the cluster as effectively as possible. What is also a major difference between traditional storage options is its storage policy-based management. Since vSAN is deeply integrated into vSphere, it uses storage policies that determine the availability and performance characteristics of virtual machines. Storage policies can be found in vCenter under the Policies and Profiles section, and clicking on the policies, we can see what VMs are associated with what policies. To see the objects-oriented storage at work, we can log into our vCenter, navigate to a virtual machine, click on Monitoring, and then vSAN Storage Placement. Since this VM is at the default storage policy, it is FTT1 RAID 1 format. FTT stands for failures to tolerate, which is indicating how many vSphere hosts in the cluster can fail and still maintain availability of the data. So here we can see a copy of data on this host, its replicated pair is on this host, and a witness component is on this host. The witness component acts as a small quorum file and is very small. We can see this change if we go to this VM and change its storage policy to FTT0 RAID 0. RAID 0 is not a production level protection method and not recommended for most scenarios, but for the sake of showing objects changing based on the storage policy, we will apply it to our virtual machine disk. After the VM updates, we can see now that there is only one object on this host for this VMDK. If we had at least 4 nodes in this cluster, we could change this VM to RAID 5, which has the same fault tolerance as FTT1 RAID 1, but Erasure coding allows data to be more storage capacity efficient. With the RAID 1 policy, you have a 2x overhead, similar to a RAID 10 in a storage array. So for every 100 gigabytes of data, you have 200 gigabytes of raw disk to add the copy. But the Erasure coding, we can get more efficiency. In Erasure coded policy with FTT1, 100 gig of data would actually be 133 gigs on raw disk. Erasure coding does have some I/O amplification, just like RAID 50 or RAID 60 in a storage array. But keep in mind that the disk group configuration for AV36Ps are all NVMe, so the likelihood of you noticing a performance impact on a virtual server is very low. Fortunately, even if you have that rare chance of a VM experiencing storage performance impact, you can set different storage policies for different disks. Monitoring vSAN metrics is integrated right into vCenter. The level of detail you get is very impressive. We can monitor guest performance all the way through the host, network, and the backend disk. To see this in action, we can navigate to the VM like we did earlier and go to Monitoring, then go down to vSAN and Performance. Here we can see what the guest is experiencing, which really is the most important metric. Most storage systems will just tell you what their response times are when they receive the input or output, but in here we can see all levels. Then, if we wanted to see performance at a cluster level, we can choose the cluster level object, monitoring, scroll down to vSAN performance. With this, we can see both front-end I/O and back-end I/O. We can also drill down to the different vSAN layers between cache and capacity drives. If you are concerned about the health of your vSAN cluster, you can explore a couple of locations. Firstly, if there is a degradation in your vSAN cluster, alarms will appear in vCenter. This is an additional significant benefit of vSAN's integration with vSphere tooling. A great starting point is to examine the vSAN health alarms. You can find these under the cluster level view, monitor, and skyline health. This shows some basic checks that are critical for storage operations. Most of these alarms will be informational only for you as the user of the AVS service because they look at infrastructure level configuration to determine health or potential issues. If you observe alarms without corresponding notifications in your service health, it is advisable to open a support ticket with Microsoft. Another valuable location to check is the Resyncing object screen. This screen is useful when you have made a storage policy change that necessitates storage resyncing. It will give you details on what objects are resyncing and an ETA to completion. If you're curious about overall storage performance and need a gauge of your cluster's capabilities, I highly recommend running HCIbench. HCIbench is a VMware configuration tool that uses open source storage benchmarking tools to give you maximum storage statistics for your configuration. VMware did not customize the actual stress testing tool. Instead, they built an automation wrapper to deploy multiple VMs on your cluster and initiate the performance tools simultaneously. It also uses Grafana and other open source tools to give you graphics to review performance details. Keep in mind that vSAN scales out performance as you add nodes. Therefore, a 3-node cluster will have a minimal performance, while a 16-node cluster will have the maximum performance. Before we wrap up our topic today, I want to make a couple of comments on some nuances with vSAN specifically in Azure VMware Solution. Let's start with Azure VMware Solution's service level agreement and how vSAN plays a critical role. AVS has a 99.9% SLA, which you can find by going to the link we provide in the description below. As you can see, for the most recent SLA document, when you are between 3 and 5 nodes, you are required to have FTT equals 1. Once you have 6 or more nodes in a cluster, you're required to have FTT equals 2. There is also a requirement to have at least 25% slack space. Monitoring your storage capacity will be important so that you do not exceed this slack space. There are a number of ways to set up monitoring within the Azure portal to ensure you get alarms once you start approaching this number. To change your storage policy to FTT2, check out our shorts on how to change storage policies in AVS. To change your storage policy to FTT2, check out our shorts on how to change storage policies in AVS. In conclusion, we've taken a closer look at vSAN storage monitoring and performance, specifically in the context of the original storage architecture utilized by AVS. Understanding the object-based nature of vSAN and its integration with storage policies provides a solid foundation for efficient resource utilization in a cluster. We explored how storage policies, such as fault tolerance and RAID configurations, impact the distribution of data across hosts. The flexibility to adapt storage policies based on specific VMs or even individual disks ensures tailored performance and resilience. If you found this deep dive intriguing, I encourage you to explore further resources, including the webinar on this channel, for a more in-depth exploration. Thank you for joining me on this journey into vSAN storage, and I look forward to sharing more insights with you in the future. Have a great day.